Good evening, everyone. A warm welcome to all of you to Technical Webinar 1 from data to decisions, from raw data to meaningful insights. On behalf of IET Student Chapter, it is my privilege to introduce our esteemed resource person, Dr. Lalin Laudis. He holds a Doctor of Philosophy and is currently a postdoctoral fellow under the prestigious Visvesvaraya postdoctoral fellowship funded by the Government of India. He is also associated with Maharashtra College of Engineering and Technology and has extensive expertise in machine learning, VLSI design, and evolutionary algorithms. His contributions to several government-funded research projects reflect his strong academic excellence and dedication to innovation. We are truly honored to have you with us today, sir. We are confident that the session will be insightful, engaging, and enriching for all of us. Thank you.
Thank
Yes.
you, Mr. Ashri, for the warm welcome. Without further delay, I invite Ms. Lalin sir to take off the session.
Okay. So thank you, Jayashree, for your warm welcome, and thank you, Akshaya, right? So for your wonderful comparing. And I would like to thank and appreciate Dr. Soumya for this initiative. She's been very curious and very particular on organizing this event, either online or offline. So her efforts has to be applauded. So I hope my screen is visible.
Yes, sir. Yes.
So this evening we have car number, car model, they are data. So with this data, how would you convert this data into a meaningful insight? So this is a raw data, and today we'll learn something about how do we manipulate this data, how do we gain some inferences in this data through machine learning and all those things. So that is the agenda for this evening, and trust me when I say I will never take more than 1 hour or 1 hour 15 minutes, not exceeding 8:15 or 8:20. So participants, please be attentive. It is usual that the evening seminars are multitasking, because you will be listening to the presentations, you will be doing your works, you will be doing writing, reading, playing, whatever. But anyhow, I would appreciate if you give me at least 1 year, so that you could listen something and learn something from this. Got it? So uh, first, why do you learn this? The first, what we wanted to know is, why do you learn this data to decision? Why do we want to take some decision? Why do we want to take and process data? As I said, data is everywhere. Wherever you go, data is being taken and data is being given. But however, the deciding factors are still poor. Mathematics. So mathematics, in basic sense, it means that you should predict something with some data. But today, our mathematics is actually is, we predict that today we will have rain, but unfortunately there will be the most at most sunshine, and the vice versa is also true. So this decision is still poor, it is not up to the mark. So we want to learn this data analytics, data processing, data cleaning, all those things, to take some meaningful decision. So why do we want to learn this data to decision? It is because our decisions are still categorized as poor. And so in order to make better decisions for our product, better decision for our project, we have to learn this data processing. So it is not that we don't lack data, but we lack the understanding behind the data. That is the fact today, actually. We have a lot of data by millions of sensors, millions of aspects, but we have not processed the available data properly, and so we are lacking the basic understanding for taking some decisions. That is the fact of today. I would like to picturize some values here. I hope you can see 120, 75, and 300, correct? Now, some data from this thing. These are three data I have given to you. You can you can assume what this data is about. Is there anyone who could infer something from this data? No one? All slept? Okay, everyone is muted, I guess. I'm sorry. Okay, so actually these are basically just numericals, but some form of data. This is what we call it as a raw data, which means it is 100% unprocessed, and there is no contextual meaning in this data, which means if we see this data, we could not infer anything. We could not infer what this 120 is about, what this 75 is about, and what this 300 is all about. So this is simply a raw data, unprocessed data, and without any context. So that is what we tend to know from this screen. Now, this is a factual in data processing people. A number without a context, we consider it as a noise, not nothing more than that. It is a noise. Any engineer will consider noise as an unwanted element in the system. So a number without a context is obviously termed as a noise. So today what we'll do is, the journey of today is, we'll see data, we'll see how this data is formulated into information, and how this information is directed towards insights, and finally, based upon these insights, how a decision making should be done. So this is the agenda for today. What is the data? How do we take and process data? How do we convert this particular data into information? And from this information, how do you transform it into an insights? And from that insights, how do you take some decisions? So this is the agenda for this evening, and I'm sure if there are people who take notes, I would like to inform you that please take these notes: data, information, insights, and decision. So today's presentation is it will be revolving around these concepts. Step one: usually any data processing, data which means not only the data which we take from Excel or whatever. An image is the data, a video is a continuous image format, and that is itself is a data. Anything coming out of a sensor, maybe an IoT sensor, a moisture sensor, a PIR sensor, anything coming out of any information that is coming out of data sensor, we call it as data, and coming from various sources. Sensors, it might be for management students, they will be having some Google Forms, Excel sheets, and what we are doing in our applications, all are a form of data. So this we call it as the data is collected from these kind of sources. The basic sources today is our mobile phone and our personal computer. They take more data than we can ever assume. They take our health data, they take our heartbeat, they take our blood flow, they take our pulse rate, they take our walking rate, they take our movement, exercise rates. All this data is being taken by the applications through some sensors. So any data which is collected from this process we call data collection. So this is the number one step of data processing. It might be an image. If it is an image, the image, from that image values should be taken. So that is basically a computer knows zeros and ones, and processing all the data in zeros and ones is always mandate. So data should be collected from various sources. The source depends upon the projects which you are doing. It might be from sensors, it might be from some forms or a manual entry, and it might also be from some applications that give some real time or some off time data. Let us I have some examples. First, since I am working in healthcare sector, in healthcare sector, heart rate is equal to 120 is the data. Blood pressure is equal to 140 is the data. Blood sugar rate is equal to 180 is the data. So these are individual data. This is the way how we should collect the data. It might be automatic collection or it might be a manual collection as well, but this is the data collection that is covers the step 1. So step 1 is data collection from any sources. An example I have given. So we collect everything, but usually we don't understand anything. Let me tell you, with this information, heart rate is equal to 120. What is the inference you could get? Might be it is normal or it is an abnormal. But the real fact is heart rate to be 120 at that particular instance. It is not always the same. Blood pressure 140 by medical terminology, clinically it is high blood pressure. But we don't consider anything before or after, which means when this blood pressure is being taken, either after walking or after relaxing, that context we have not taken, and hence this is just a raw data we are just collected. That's why I said we collect everything, but from this collected data we could not understand anything. So this is the end of step 1. So step 1 is data collection from various sources without any interpretation or whatever, just collection, blind collection. Now comes the step 2, that is data organization. So we have collected several data. Usually and traditionally, the collected data will be handled by an Excel, Microsoft Excel, or some sort of this analytical tools, and they will be saved in a CSV format or Excel format. That is very helpful for the modern computers to take up those data and process that data. So today, even today, we will be collecting. I have always collected data in the form of CSV files. Let us say, example, age, blood pressure, and sugar. This is a simple tabulation. You can fill this data as many as you want. So the second step is just organizing data. Organizing data is just collect the data and make it into a readable, appealing format so that it should be machine ready in the next future few steps. So the second step is nothing but data organization. The first step is data collection from various sources. The second step is data organization. Now comes the third step, and usually people consider this as the first step. The step 3 is data cleaning. Any information without an analysis or without a proper processing, it is of useless. Actually that happens today, when we today the hot trend is like US Iran war. Everyone wants to talk about it, everyone wants to make conspiracy theory out of it, but we do not know what actually is happening. So there are information, but we have not yet cleaned the data. Our brain is processing the data as such, and we are always forefronted to spread the rumors and conspiracy theories as well. So usually it should not be done while computing with machines, while dealing with machines. After data organization comes the very important part, data cleaning. So during this data cleaning, what actually happens is while collecting the data, there might be chances that we might miss certain data, we might miss certain values. There is also a chance of wrong entries. We might manually, if when we enter the data manually, there is a high chance that we will enter a wrong value. And again, while the processing is done very fast, there is a higher chance of duplication as well. So normalizing all these facts, that is missing values, wrong entries, and duplicates, constitutes data cleaning. That is the third step. The first step is data collection. The second step is data organization, and the third step is data cleaning. I will give you a practical example. Let us say when you see an age in your Excel sheet, when you see an age to be 250, what you would assume? Either the man is a superman or a godlike man, or your machine is a fault one. So usually in practical, age is equal to 250 is not attainable, and hence this data is a false data. It has to be cleaned somewhere. This is wrong entries. Okay, this constitutes the wrong entries. And also when you see a percentage attendance equal to 110 percentage, how do you take this? This is a wrong entry. This has to be cleaned by some means. Maybe by taking a mean of average of other values, or by using some other mathematical models, median, mean, mode, all the statistical models. You have to replace, or you have to rewrite, or you have to clean this data to a normalized one. You have to normalize when you see this data. But you know what? While processing the data, it is not that we are dealing with 10 entries or 20 entries. Usually, the minimum entries will be 3,000, 5,000, 10,000, and more than 10,000. So as a human, it is very difficult to examine all the cells in the Excel file to see whether it is correct. So that is why we employ some codes. So when the age is let us say the input should be, the programming should be, when the age is more than 120, then take the mean of the replace the entry with the mean value. When the attendance is more than 100%, either make it 0 or take the mean of the other days the person is presented. So when there is a blank data, duplicate transactions are removed. Blank data, and also the duplicate transaction should be removed. So this is what we call it as data cleaning, and this is the primary and the more important step in data processing for decision making. So the step one is like you collect the data from sources. Step two is like organize your data, and step three is like data cleaning. And factually, a clean data is directly proportional to trustworthy decisions. When your data is very clean, it means that okay, my decision will be perfect. So that is why it is very important when you give millions and millions of data to a computer to compute, to the machine to learn. It is the data should be very clean, and so that the machine gives us the trustworthy decision and the correct decision as much as it could. So this constitutes the third step. Now coming to the fourth step, data transformation. Data transformation. So what is data transformation is like scaling the data. Let us say in age 1, the child learns 1 word. In age 2, the child learns 4 words. In age 3, the child learns 8 words, which means in age 5, the child should learn 12 words. So this is what we call it as scaling. With the available data, we are manipulating the data for more number of iterations. So that is what we call it as scaling. And we also encode the data for memory process, for better usage of memory. Usually, in a computational perspective, when there are millions and millions of data, usually the system struggles, because our system is maximum 64 or 64 GB RAM or SSD or whatever, but it cannot handle more than millions of data, because even though it has a constraint. So that is why we try to encode the data so that the data becomes very simpler, and also it is compute friendly for the computer. So encoding process is also an important process which comes under data transformation. And also normalizing, as I said in the previous, you have to normalize certain data. How do you normalize? We have certain mathematical models, mathematical methods through which we can normalize the data. So the fourth step is like data transformation, through which we do scaling, encoding, and normalization. I'll give you an example. Let us say income 1 to 20 lakhs, age 18 to 70. So with this thing, we can scale the data. And also there is an optional like male or female, we can encode it as 0 or 1, despite of writing MALE, which takes 4 character. Excuse me. Despite of writing MALE as 4 characters, you could replace it by 1 character 0. Also FEMALE, that is, you can replace it as 1. So you can encode the data so that it is very easy for computational points. So after completion of the step 4, that is data transformation, look back. Data one is step 1 is data collection, step 2 is data organization, step 3 is data cleaning, and step 4 is data transformation. So once this transformation is complete, our data, it is ready for machine. The machine is ready to take up this data, and it is like the machine will be machine will be more adaptable so that it can process this data. So after step 4, your data is ready to be fed into the machine. Now comes the step 5. Step 5 is nothing but dimensionality. So when I was discussing this topic with Soumya ma'am, what ma'am informed me was there are students who are struggling with that dimensionality, which is single dimensional or multi-dimension. People are students are doing projects in multi-dimensional, so when the accuracy factor is getting differed and all those things. So first we'll see what is dimensionality, then we'll see what actually the problem is occurring in your computational point of view. So usually in dimensionality, there is 1 dimension, 2 dimension, and also multi-dimension. I'll give you an example of 1-dimensional data. Let us say if your heartbeat is 120, what would be the decision? Whether would you classify the particular patient as an hypertension or a stressful person with only this data? Is it possible? Practically, it is not possible. With one data, you can usually as a in a teaching perspective, we'll say the student learns well, the student does his homework, everything, and that does not means that he's a best student. Only learning factor does not decides that the student is a best student. The student must involve in projects, student must be obedient in the classes, student must have a very good attitude, student must be bold. All these factors contributes the best student in the class. So with only one data, that is with 1-dimensional data, it is practically impossible to attain a decision which is almost precise. So usually in computational point of view, 1-dimensional data is not at all used for taking some decisions. Now factually, single value is directly proportional to weak at decision. When there is a value is only there is 1-dimensional value, then the decision will obviously be a weaker decision. Now I'll give you an example for 2-dimensional data. I will consider heart rate and age. Let us say a 16-age patient or 16-age person who is having a heart rate of let us say maybe 150 is considered to be ill or okay. It is like a 16-age student, 16-age fellow or a young person with a heart rate 150 is manageable because he might have run, he might have walked, he might have, that things get differs. But let us say if the age factor is high, let us say if an age is 60 plus, and when the heart rate is, let us consider, more than 120 or below 60, which means that there is a chance that there is some abnormality obtained. So usually the 2-dimensional data can be used for processing. A 2-dimensional data can be used for processing to take decisions, but not the final decision. So a two-dimensional data can be used for computational purpose, but it is not that is the exact final decision. So it is where the pattern begins. With two-dimensional data, the pattern begins. The patient pattern in healthcare perspective, patient's patterns begin. So when students ask me, can I use one-dimensional data for decision? No, you should not use one-dimensional data for decision making. Okay, sir. So can I use two-dimensional data for decision making? Again, the answer is partial, a quasi state. You can make a decision, but that is not the final decision. So dimensionality, one-dimensional, second, two-dimensional. Now comes the multi-dimensional, and here let us consider the same example: the heart rate, the age, the activity he has done, and also his body temperature. So with all this data, we can come to a conclusion whether the person is normal or not. Because heart rate gives you the particular rate of a heartbeat. Age you can predict, you can use it. And what is the activity which he has done while taking the heart rate? So if it is a walking or if it is a jogging, whatever, then the heart rate should be obviously high. And what about the temperature? If the temperature is very low, it means there is some problem. His body is dysfunctioning. If the temperature is pretty high, okay, it should be mapped with the activity and the age. Okay, so with this multi-dimensional data, we can take some decisions. So usually while computing, you are advised to take as many as dimensions as possible for taking better results. And also all the dimensions should be related to each other. Traditionally in our family we'll say that relationships create meanings. Relationship creates meaning. So the same way in data engineering, when your dimensional data are related, they create, definitely they will create a meaning. So while doing some projects, you are advised to take as many as dimensions. And dimensions are nothing but values, as many as set of values and factors to be considered for taking some decision. So they will create a meaning for you to obtain a better results. So usually, theoretically, accuracy impact is, if you have one-dimensional data, your accuracy will be less than 50 practically, but theoretically it is 50 to 60 percentage. And when you take two-dimensional data, it is 70 to 80 percentage, but in practical it is less than 60 percentage. And when you take multi-dimensional data, your accuracy falls around 80 to 95 data. And when the multi-dimensional data is increasing, the more the data, the more the accuracy. So the more the dimensionality, the more the accuracy. So that is what we come to infer from this particular step 5, that is dimension. I'll just recall once again. Step 1 is data collection. Step 2 is data organization. Step 3 is data cleaning. Step 4 is data transformation, and from where you can give the data to the machine. Step 6 is dimensionality, and step 6 comes the exploratory analysis. So what is actually an exploratory analysis? It will have the factual trends, it will have the factual patterns, it will have the relationships with each other factors, each other dimensions. So exploratory analysis, I will give you with an example. Excuse me. Okay. Sorry. I will give you an example. Consider a person with the body mass index is high, which means here his height and weight proportion is not normal. So he is termed as high body mass index the person. If the body mass index is high, it means that he has some extra fat in his belly or in his body. body mass index, if it is high, it is directly proportional that you will have some extra fats around your body or belly. And obviously, if you have some extra fat around your body, your locomotion, or your movement will be restricted, because with the heavy body you are constrained to move. So the problem started with high BMI, which from that we can say that the person have a very higher fat rate. When the fat content is high, his mobilization is affected. If his mobilization is affected, which means that his insulin tolerance will be affected, and obviously he will have a high blood glucose sugar. And if his blood glucose level is high, obviously there will be somewhere it is associated with the metabolic functions and directly proportional to blood pressure and heart rate. So with just one data, high body mass index, we can assume that we can exploratory analyze that this person will have a high blood sugar, this person will have some high blood glucose, this person will have some insulin intolerance, and this person will have some lung disease. All the things are interconnected, right? So this is something we call it as storytelling, data storytelling with data. So if a person has this one data, there might be a chance that this can move as this trend. And again, usually the tea shop or some sales places, when the sales rate peaks, so what is the factor that affecting that sales peak? So these are all things that we term under exploratory analysis. So this phase, actually we call it as storytelling using data. This is not that something that has to be programmed, but this is something that has to be analyzed by a programmer while doing the calculations. So exploratory analysis step, you need not directly go and sit and program. There is nothing to program, but you have to take this as a constraint while analyzing the data. So step 6 is exploratory analysis, where your data will tell its story itself. And next comes the very, very important part. That is what we call it as feature extraction. So what is the feature? We have already seen dimension. So from the dimension, what makes this features different? Let us say my speech signal is a dimension, but my speech signal will have several other data. Let us consider jitter, shimmer, Mel frequency septal coefficient, and there are 44 features in my speech signal alone. So we have to, from this one dimensional data, we have to decipher all the features. So usually it is like more than 40-50 features will be available for 1,000 to 10,000 data for processing. So more the feature, again better the better the results. So it is like from ECG you can take heart features, PQRS values, and the heart rate. All those things we can take from ECG. That is, it is from the raw data we are taking from meaningful values. That is what we call it as feature extraction. Let us say people who are doing projects with facial recognition will have 6 features. Eye aspect ratio, they will have 5 or 6 features. Facial recognition, they will have some features. So from the facial image, that is one dimensional facial image, we are taking numerous features as values so that we can compute it for better results. Another one example, from transactions, from the spending patterns we do, we can observe the frequency of spending patterns. Which time do I spend more? Which dates? One day from salary, definitely I'll spend more. 5 days from salary, definitely I'll spend more. 10 days from salary, my spending behavior will decrease a bit. And 15th to 20th day, 20th day to next 30th day from the salary, my spending will be completely minimized. So these are some of the features that we take from the dimensions. So this is called feature extraction. This is the seventh most important step of the data processing. And in this step, we convert the signals, the basic signals, into some form of intelligence. So we convert the basic signals, that is, let us say, speech signal, or let us say a video signal or an image signal, into some sort of intelligence. We are coming towards intelligence now. With the basic and raw data, we are moving towards some features, some mathematics we are taking from it, some max values, mathematical values we are taking from it, some patterns we are taking from it. So all the features are being extracted and saved in an Excel sheet or whatever, or any form of the data storage. So here we are converting the signals into intelligence. So the next step, feature selection. Now, practically, when you consider, let us consider my healthcare problem, there is not only one feature. If you consider for a single disease, let us say, if you consider for heart, cardiovascular disease, CVD, you will have around 30 to 40 features. But it is not that all the features are important. It is not that all the features are needed for processing the cardiovascular disease. So in this stage, we'll have a problem like feature selection. We have a step called feature selection. So feature selection is nothing but from the available data. During the first phase of the data collection, we will collect as many as data we can. We will collect number of data. But for a specific purpose, it might not, it is not practical that all the features are needed. So in this case, example, for a disease prediction, to predict a disease or to classify a disease, to diagnose a disease, age is definitely a feature. Blood pressure, definitely a feature. Blood sugar level, definitely a feature. But favorite color of that particular person, it is not a feature for disease prediction. With the information, which color do you like more? Can I predict any disease practically? Theoretically, no. Practically as well, no. There may be some conspiracy theories. Those who are associated with this color will have this disease and all those things. But factually, this favorite color feature is not necessary for computing a healthcare project. In this case, we will just ignore favorite color feature. So this is what we call it as feature selection. It is simply like remove the unnecessary. So feature selection is like remove the unnecessary. So by using feature selection, let us say n number of features will be reduced to n minus, let us say, g number of features. So g is the unwanted unnecessary features. So you will have a better data. It is the data is evolving from the collection for proper processing. So in this feature selection set, you will have we will have the unnecessary data, unnecessary features removed from the data set or nullified from the data set. So there comes the next step, that is called feature optimization. Consider for a healthcare application, there are 40 features. Out of 40 features, 10 features are not necessary. So what we'll do is we'll completely nullify the 10 features. But again, 30 features are there. Excuse me. Sorry. But again, there are 30 features. Assume that with the computation power of, let us say, 8 to 10 GB of hard drive, the processing time will get much more higher with 30 feature set. In this place, there is a technique called optimization. One minute. Okay. In that case, the computational time will be much more higher when the data when the data features is much very much higher. That is, if in a data set you will have 40 feature, 10 feature we are removing as it is not necessary for the particular application, and that step we call it as feature selection. Still we have 30 features. Now it is not that we wanted to use all the 30 features. If you have a higher computational machine, if you have a very good infrastructure, well and good, there is no problem in running considering all the features. But practically, when you are running out of computational power, when you're running out of space complexity, all that thing happens, then you're mandated to optimize the feature. So what is optimizing features is assigning importance to the features and also improvising the feature combinations. It is not that um, all the features are taken as it is. The weightage shall be distributed so that the more important parameters or more important features will be prioritized for computation, and the less prioritized will be neglected, or it can be used only in the worst case for decision making. So this process is called optimization, feature optimization, and we have n number of algorithms for optimizing. But in my perspective, if you are going for optimization, then use naturally inspired algorithms like evolutionary computation, genetic algorithm, and colony optimization, particle swarm optimization. So these optimization algorithms provide very good solutions for your optimization problem. So now is the answer for people who ask me, why even if I increase the dimensions, I am not getting better results. It is because you have not optimized your features. So incorporate an optimization technique with the features, and I'm sure you will get a better result. I am working on healthcare problems and VLSI related problems. For both of these problems, I have utilized optimization algorithms before processing. I have got 80 to 94 percentage of results. That results varies upon projects, but I have got good results comparatively when the feature optimization is not employed. So it is always advisable when you go for a problem, you are mandated for feature optimization. So consider if the features are age, blood pressure, sugar, and cholesterol, you will assign the weightage for this. So sugar 40 percentage, blood pressure 30 percentage of importance weightage, age 20%, cholesterol 10%. It depends. It is just an just a representation, but it might not be perfectly correct for cardiovascular disease. But still, this is how you assign the values for weightage, so that your data set becomes more optimized. More optimized data set is directly proportional for higher computational speed, and also better results. It is not that only higher computational speed is needed, but it is also that your final classified output decisions should be more reliable. Trust me when I say, I had the experience of running all the features for a problem, and it took me 1 or 2 days, but still it could not complete the simulation. So I have met with that problem as well. So employing an optimization in your data processing is always mandated. It is always advisable for by data engineers, so that you will optimize the computational speed and also accuracy. So the step 10 is model building, which means we learn the patterns, predict the outcomes. And recently, I met a student who was very new to data engineering. He had a very good number of data set, but the problem is he has taken all the input parameters, but not he has not tabulated the output parameters. for a proper model building, you should have input parameters as well as output parameters. It is like this student has scored this much, and he has got the first mark. The input should also be there, the output should also be there. Only with that your model will be more and more efficient. So when you form patterns, when you take data, it is always mandated you take the inputs and also you take the outputs, so that their model builds very well. Next is training and testing. This comes in more into practical training based upon the past data, test on the unseen data. So your model will be trained on the past data. The past data will have the input parameters and also the output parameters, and we will train the model and all, then we'll test the model using unseen data or unclassified data and check if the data if the model works very well. So this is the 11th step of data to decision making, and this is almost near for the end results. So when you enter into the training and testing, test on the past data. The problem actually occurs here. People who have done projects on machine learning, the training time will be much higher, and our systems probably will never complete training data in at least 1 or 2 hours. No, it won't complete. So usually we will go for predefined models or pre-classified models. Let us say, for example, people who are doing with image processing might be aware of YOLO module or har cascade models. You will use these models for performing. But when you create a own model, when you implement this optimization methods, the training, the model methods, everything becomes very smooth, and it should be manageable. So this is almost nearing to the final decision making, the training and testing of the data. So here it is like the real intelligence work on the new data. So intelligence was built from the previously available data, and it is now working on the new data. We are testing it using the new data, and also we are giving a feedback to the machine that it is correct or wrong, so that the machine will learn from the new data as well. And the final step, it is like evaluation, and this is the more important step, like the first step. The first step was like data collection, and the 12th step is like data evaluation. So the data evaluation is like more important. We check it very clearly for precision, accuracy, reliability, and there are several confusion matrix should be done, F1 score should be done, everything should be used for evaluation. Because when you are dealing with, let us say, health data, wrong prediction definitely can cost a life. So a small mistake in the data and small decimal variation in the data can definitely, if a wrong decision is taken, it can cost more life. Because let me give you an example. In Regional Cancer Institute in Trivandrum, there is a project called treatment response. How do the treatment response occurs for a cancer patient? Assume if there is a 0.0001 percentage error, the patient will be given chemotherapy next phase also, which means the life is affected. So usually while dealing with medical data, it is a mandate process for evaluation of the in step one, data collection. In projects, when you are dealing with student data, business data, when you are dealing with weather data, everything will have some interconnections. Let us say if you are dealing with business data, if there is one mistake you have done, then your total business might collapse. Your decision will collapse the complete business. So it is like, it is a responsibility of the researcher to execute step 1 and step 12 in a very, very, very meaningful and efficient and responsible manner. Now comes the step 3. It is like insight generation. So when the risk is higher, yes, you will have sugar, you will have blood sugar, obesity, family history, all these things are taken, that is mapped with that particular insights. Usually when you speak about insights, it explains why it happened. Let us say, if the person is diagnosed with some greater risk, it might be due to high blood pressure, sugar, high obesity, and also this victim might have a family history. So because of these factors, the risk factor has increased from 0 to 85%. So insights usually explains why it has happened. So this is also important for decision making. And coming to the final step, it is decision making. It is an yes or no or whatever. Sorry, excuse me. Sorry. So this is the final step where you decide on something based on the available data, based upon the training you have done to your machine. The machine gives some answers. Machine decides for you. So with this lot of available data, 10,000, 20,000 or lakhs of data, I am making a decision. Yes, now you can do this. So this comes to the end of the data to decision. So usually decisions are not made from data alone. They are made from the relationships between the data and also the optimized feature which you are giving for computation. This is just a quote like thing. So the entire framework will follow these methods: collect the data, clean the data, organize the data, analyze the data, extract the data, select the features, optimize the features, decision. So this is how the framework operates or works. So raw data speak nothing usually. Structured data whispers something. Yes, in a husky voice, structured data will have some information. And optimized multi-dimensional data, definitely it will reveal the truth. And when a truth is identified, it drives to a proper decision. So raw data speak nothing, structured data whispers, optimized multi-dimensional data reveals truth, and the truth drives the decision. Usually, historically, data has been collected that if you want to be a high performing person, you should work in a peaceful environment. So in a day, when the peaceful environment happens is in the early morning, let us say 4:30 or 4 to 5 or 5 to 5:30 before sunrise. So when you want to work in before sunrise, it is mandated you should have a proper 7 hours sleep, which starts from, let us say, 8:30 to 9 o'clock. So to perform well, data shows that you should sleep well. So now it is a time for you to sleep well. So with all these insights, I conclude my session. This is my what is the email ID and all those things. So I'm a postdoctoral fellow working under Visvesvaraya postdoctoral scheme under Ministry of Electronics. My nodal office is St. Saviour's Catholic College of Engineering. You are always free to email me your questions, your clarifications, your comments, your feedbacks. It is always welcome, so that I could enhance myself with your data. I could evolve my decision making with your data. And also you can follow me on Google Scholar, LinkedIn, and also I write on Medium. You can find me. So one or two questions is welcome now. I would appreciate if you have the time to write something questions to me, so that I will respond to you. And also thank you very much for listening, everyone. Thank you, Soumya ma'am, for organizing this wonderful event. I think I'm on time, sharp 8. Thank you, everyone.
Dear students, if you have any queries, you can ask. We can take 5 more minutes.
Sure, ma'am.
And
Hello,
other,
sir.
yes, other queries you can mail him. Okay. I hope you have.
I'll put my email ID in the chat box.
Okay.
You can write to me anytime, and you can always contact me for projects, some guidance or whatever. I'm always open to helping.
Yes, Jayashree.
Hello, sir. We are doing a mini project on ECG classification using deep learning.
Okay.
So one problem we faced was that while training, we did both. We did the training both on 1D and 2D CNN. However, we found out the accuracy of 2D CNN to be lesser than that of 1D CNN.
Got it. So you are the culprit who was Soumya ma'am was informing me, right? Okay.
Yes, sir.
So have you
I am
optimized?
the kid.
Okay, okay. Jayashree, have you optimized the features?
Uh, no, sir, I don't think so.
Okay.
We had taken amplitude and time.
Okay. No,
So
no. How many features have you taken? A number of features you have taken from ECG?
not much, sir. We took only amplitude and time.
No, you should take much data, time, let us say the patient details, patient extra add-on features, all those things. Try an optimization before processing.
Sir, how in what way should we optimize, sir? Like, how is it done in MATLAB?
It is like you consider for an ECG perspective, what are the features you are taking? Time and amplitude alone, right?
Yes, sir.
Let us consider. I'm not sure, but in my assumption, you can take the age, you can take the geographical position of the person, you can take the nature of work of that person, you can take the family history of that person. These are the features. So when you add on this many data, your data gets more complicated. So you will complicate the data and then you will apply some weightage for this thing. In this thing, for a cardiovascular ECG inference, let us say stress is a major factor, correct?
Yes, sir.
Stress is directly proportional to the environment which you are working,
Yes, sir.
correct? And stress is directly proportional to the spouse you are associated with.
Yes, sir.
You have a good spouse, your stress level will be low. You have a good workspace, your stress level will be low. So associating all these features, and within this you can allocate weightage. The more weightage, lesser weightage, all those things. And you can design an optimization algorithm, select the features what you want, and then you can go for computational deep learning or whatever. Then your results will be more polished.
Okay, sir. Sir,
Jayashree, learn about what are all the features that we can add with this data. You are processing with just two-dimensional data. What I said was, like in the presentation, if you heard something, two-dimensional data can be helpful, but not for the final decision making. So you should have some multi-dimensional data.
okay, sir.
Okay, and for people who are doing with medical data, definitely you may have come across with a problem like no data sets there, correct?
Yes, sir. Yes, sir.
No hospital is going to help you, no government websites is going to help you, no online platforms is going to help you. In that case, we are bestowed with a concept called synthetic data. You can note it down: synthetic data, where you can manipulate the data on your own. So let us say age, I am assuming age from, let us say, 25 to 60, 65. This is the bell-shaped curve. So you can distribute the values from 25 to 65. In the similar way, you can take the features, you can give some probability distribution, and you can synthetically create data on your own. You can test your model with the synthetically created data, so that it would be very helpful for that analysis part. You cannot do it clinically, but still your model works. You will have the confidence that your model will work. I am dealing with Parkinson's disease speech signal, I am dealing with cardiovascular disease, I am dealing with diabetes prediction, I am dealing with glaucoma. I have solved certain diseases. In any disease I didn't get any type of data. What I did was collect few data, let us say 10 to 15 data, real data, with that real data, manipulate it, synthetically generate 1,000, 10,000, 3,000 data. So your number of data will be more, your number of features will be more, so that you are obviously your decision will be very much. So more the experience you will get to the machine, more the refined is the answer. Got it, Jayashri? Try
Yes,
it
sir.
in that way. If you face some hurdles, you contact me through Soumya ma'am. Definitely, I'll help you.
Thank you, sir. Sir, one more doubt.
Sure.
We had implemented federated learning to improve privacy as well. However, in that case, also the accuracy fell down a lot to 77%. So,
How many features you take? Have you taken for that?
sir, we not much features, sir. We did the same thing for federated learning as well. Is it because
So,
of the same reason?
So my answer will also be probably the same
Same.
for this
Yes,
question
sir.
also. So, just in reality, more the features, better the results.
Okay, sir.
More the number of data, better the results. Features you can add by researching. Number of data you can create it by synthetically. So that will be the solution.
Thank you, sir.
So, how is this data generated synthetically? Is it like writing a code or
You can
um,
write a code. It is like in Max you will see probability distribution, correct?
yes,
So
sir.
by data synthetically generating data is purely based on statistics. You learn statistics, you learn how the distribution is going, and with this program using Mr. Anthony, your pet is barking on me. Thank you. Okay. So, Badra Nair, for you. So, you can create the data using mathematical formulations only. That depends upon, for various data, the mathematical formulation shape will be different. The probability distribution will be different, that you have to research upon. And then you can use Python. Usually, for data handling, Python is best, unless you go for some peripheral interface or whatever. For basic data handling, Python or software, just capital R software is used for all those things. I would appreciate if you go with Python for data classification. So, Badra, I
Okay, sir.
think I gave an answer for you.
Yes, sir. Thank you.
Okay, ma. Anyone else? So definitely there are 33 members, my favorite number. So definitely here 30% of the people will be introverts. Definitely you are warm welcome on my inbox. You can write anything, you can ask questions, you can ask for help, whatever. My time for you is open always. So
If
if
there
there
are
is
no
no
more
more
questions,
questions,
can we wind up the session?
yes, please.
Yes, Anthony.
Special thanks to everybody who joined for the session. A special thanks to Lalin Laudis sir for conducting this session. And a special thanks also to Soumya Miss and Jayashree Chachi for coordinating the event.
Thank you, Anthony, and thank you, Anthony, for your pet and your appreciation given to me from your pet. Okay, I love pets actually.
Oh, okay, sir.
Okay.
Okay. Anyway, from my side, special thanks to Lauren sir. I know you are very busy and you sleep by 9 p.m. Thank you so much, sir. It is 8 p.m. It's 8:10. So I think you can sleep now peacefully. All the questions will be in your inbox.